seeing all this wood around me. This has to be turned into a complete sailboat. One important thing I forgot to mention is that we have very little time to build this boat. We're starting to build in November, and the idea is to put it in the water already sailing by mid-December. As time passes, the editor will show here how many days remain until the sailboat sets sail. Here we have pretty much 100% of the materials for the boat. There are 4 sheets of plywood, which is wood made of several layers, one on top of the other, but they're very thin. There are 3 sheets of 6 millimeters and 1 sheet of 10 millimeters. The idea behind these thin sheets is to make the boat extremely light, and there are 2 secrets to making the boat very strong. At Manuel do Mundo, everything glued or joined uses epoxy resin, one of the strongest materials we know. And in several places, we also have fiberglass reinforcement. But that's not all. The boat also has several points that increase its strength. All of this is cedar, the brown wood at the bottom. It's much more durable than plywood, but we have to use it very carefully, because every little piece of cedar you add, you gain weight on the boat. Let's get to work. The method we're using to build the boat is called stitch and glue, which comes from English, meaning cut and glue. Thinking about how clothing is made, if you remember that Barav episode about jeans, we're at that moment when the machine cuts the fabric, right? It cuts the flat pieces so we can sew them together into one piece. Just like with clothing, here we also have the pattern for each piece that came in the manual of the boat we bought. We couldn't cut it with a laser, use a projector, or anything similar. So today we're using a jigsaw. It's not that much work because it's an extremely thin plywood. We can't make any big mistakes because this is going to stay on the boat forever. There's an issue with this wood. See here? The plywood is missing some filling at this spot. There's just a very thin layer holding the wood together. And here, it broke. Look, there's only the outer layer, and inside, there's nothing. This really weakens the hull. What do I think we should do? Fix it from the outside here. This hull will have 2 layers of fiberglass underneath, so it will hold. It won't break anymore. Here it is with a little charm. It's wild to see the 2D drawing and realize it'll become a boat once assembled. And it's also weird to think that I'm gonna have to spend 24 hours in there, but let's go. One difficult thing to do now is to mark the holes. Where we're gonna sew, we have to make a hole in one piece, a hole in the other, and then sew them together. If we make a 5mm mistake, there will be a 5mm misalignment between the pieces. It might not seem like much, but imagine if your car door was misaligned by 5mm. Here we took a shortcut. The pieces of wood have to fit edge to edge, but this joint is angled. The pieces of wood won't be on the same plane, right? One piece of wood fits here at a 45-degree angle to the other. The wood's edge is kind of odd, right? Picture this one fitting into that one, corner to corner. The fit isn't perfect, so we'd have to shave down the edge of both pieces of wood so they'd fit together better, right? So they'd be flush with each other. Normally, in the boat building course I took with the folks from Madeira Mar, they do this using this tool here, which is a hand plane. So there's a kind of little blade underneath here. As you run it over the wood, you wear down the wood, you take off thin shavings of wood very delicately. We have years of experience using an angle grinder to make perfect curves. This here, for example, was a block that we turned into a sphere using the angle grinder. So I think we kind of have some creative license to ditch the hand planer and use an angle grinder to shave down the edge of it. This is the most anticipated part of boat building. The moment when 2D turns into 3D. Now it gets more fun. That's the magical part. All these pieces are flat. We start putting them together, and they start bending. They start curving, forming a 3-dimensional shape. This is when the boat truly comes to life. Basically, we run a Hellerman tie through the 2 holes, tighten it a bit, leave it a little loose so we can adjust it, and the boat starts taking shape in our hands. Here, we had a problem when we closed all the ties. The width of the widest part of the boat was supposed to be 1 meter and 20 centimeters, but we noticed it was coming out to 1 meter and 8 centimeters, much smaller than it should be. When we forced the boat's width to 1 meter and 20 centimeters, by adding the wood, both ends, the stern and the bow, would lift up, and the boat would become completely crooked. We should have secured the strips first, then. Anyway, we secured them first. Now we'll have to remove all the strips and do it again. Good luck to you guys. I'm going to a meeting. I need to go to a meeting. The little boat will be in the hands of these two here, okay? Lucas and Danny, take good care of the little guy, okay? I hope when I come back it's already sailing. We used a piece of wood to hold it in place and force it slightly, removed all the seals, then replaced them. We managed to get to the ideal geometry here, but there's a little problem. We're going to apply epoxy, and there are several gaps between the pieces of wood. Look at the hole here at the stern. We even had to put tape on the other side, so that when we apply the epoxy, it doesn't all leak out. But let's do it, right? Time for the glue. So far, the boat structure is all loose, but that's where the glue comes in to permanently join one piece to another. We're going to use epoxy resin. There are several different formulas for this resin, but the one we're using here for this, it's an extremely viscous, very thick one, and we still mix it with sawdust. It forms a kind of brown paste. We apply it to the joints and fill the space between the two pieces of wood. But that's not all. The goal is to round the edge between the two wood pieces. Since the angle makes fiber application difficult, we fill the area with epoxy resin, which hardens the spot. This will serve as a kind of rib for the boat while this brown putty is still wet. Before it hardens, we put the fiberglass on top. And here's the big secret. The fiber we're using is this one, okay? It's actually a fabric. The big advantage is that it's a super resistant fabric, right? So these threads, if you try to pull them, they're extremely strong, but the fiber is flexible, it's soft. You need something to harden the fiber, and that's where the epoxy comes in. Epoxy is something similar to glass. It can withstand a lot of weight on top. It's extremely resistant, but it doesn't hold up well if you pull it. So, when you put the two together, the fiber and the epoxy, you get a material that we call a composite, right? They're two different materials that, together, combine the strength of one with the other. The next day, when the reinforcement we applied to the joints has cured, the boat is completely different. The epoxy has hardened. This is insanely strong now. You have no idea how much of a difference it made. Look, it's hard. These reinforcements here make the structure gain a sort of skeleton. Tapping it, the boat feels totally different. The cool part is, we're now working with its final shape, which won't change, only additions from here on. We can already start removing the Hellerman tape. It won't come off in one piece, so I have to cut it here with these pliers, flush, and not leave any Hellerman tape sticking out. Whatever's left inside the boat stays there. It's going to live with the boat forever. And then we take, once again, that brown putty and start applying it to all the little holes, all the imperfections in the hull, since the epoxy will harden later. Mixing it with sawdust will create something like epoxy with fiberglass. So, we can kind of fix all the problems there. In the bow of the boat, for example, we had a spot where the pieces of wood didn't fit together perfectly. There was a hole and opening. What did we do? We put masking tape under it, right? Placed adhesive tape underneath and fully covered it with epoxy. Houston, we have a problem. Look, there's a hole in the plywood here. That's that old hole we showed when we were cutting. And look, the plywood is cracking all over. Listen to the noise. You can't have a hull like this. This is an absurd weakness in the hull. We're gonna have to make a really well done patch in this spot. Once everything is set, with no loose Hellerman tape, and all holes covered, then, yes, a real fiberglass mat comes in. A layer goes inside the hull to reinforce the spot where we stepped there. Otherwise, it would leave a mark on the wood. Anything you drop inside the boat could make a dent there. A little hole, right? And 2 layers go on the outside to really reinforce the hull. so it can hit anything. And if we think about the fact that they're using 6mm plywood on the bottom of the boat, just the wood alone wouldn't hold up if you stepped there. It could form a hole, but by reinforcing it well with fiberglass, there are 3 layers after all. It's very well reinforced. There's a small problem: the finished fiberglass is very transparent, and we didn't leave any air bubbles between it and the wood. That's good. But isn't there a texture on the fiberglass? It ends up like a kind of hardened fabric. When you run your hand over it, you can feel the texture. It's very noticeable. That's bad for the boat hull, since water flows over it, and everything must be extremely smooth. So, we make a mixture of epoxy with something called aerosol, which is this right here. It's pyrogenic silicate. It's a kind of sand that has been melted, and then, I was going to say sprayed, but it's blasted in the fire. But when you mix it with the resin, it forms a little paste. We spread this paste over the shell to cover all the little holes and remove the texture. It's kind of like a filler. You have to protect yourself really well so you don't breathe in glass dust. Me and Lucas had to dress as astronauts to sand it, wearing a face mask and goggles. And that's why. Because, besides being bad for your breathing, fiberglass also sticks to your arms, gets on any area of your skin, and starts to itch a lot. It's like a kind of thorn that gets into your skin. Friday, 10 o'clock at night. Look who came to save me, here with the task.
Me! Right, me!
And what did you think of the result, Mary?
I think it's looking beautiful.
Do you want to ride this boat later?
Only if it's with you.
Thinking about the waterproofing part of the hull, right, and reinforcement. The hull is ready. If it were another time, we could already put this boat in the water, because it's already better than all the boats we've made on Manual do Mundo, except for the submarine. It's not for nothing, but I think the pool is calling this boat for us to give it a little test. 1, 2, 3, and we really wanted to put the boat in at that moment, but I thought it over. And if we were to compare it to a house, it's like we've built the walls of the house. You can already see its shape from the outside. You can go inside the house, imagine what it's going to be like, but it's completely unprotected. The house can't handle a storm yet, so you need to install the door frame, door and windows. What we're going to put on the boat now is going to make all the difference. It's a reinforcement called a rubbing strake. It goes on the edge of the boat. We're using cedar, which is more durable and attractive than plywood. I need to break the edges with the router, which is a machine with a bit at the tip that you use to cut the wood, and round off its edges. It's very important to round everything on the boat. Any sharp corner, when it gets hit, breaks, and if it breaks, water will get in. So, having sharp edges on the boat is a weakness. But anyway, on the rubbing strake, a strip of wood goes on the outside, all around the entire edge, and on the inside, we're going to put little blocks of 15 centimeters, spaced by holes of 15 centimeters. Then another strip of wood goes on. When we put everything together, it creates a kind of row of holes on the edge of the boat that we use to tie a lot of things. Tie the ropes. Tie something you want to have access to during navigation, and so on. To me, this is the most beautiful part of the boat. Not just for its looks, but because it makes the boat seem very sturdy. Made with 6mm plywood, it looks ordinary from above, but it's actually a very strong boat. Installation is tricky, since we can't use screws. None can remain in the boat unless fully covered with epoxy. First, screws rust. Second, if you have something very hard in the middle of a softer structure, like wood, when you bend that structure, when it flexes, the hard part will damage the softer part. About 10 centimeters below the rubbing strake, we added a cedar reinforcement to strengthen the boat. This was our only option. We drilled the hull from the inside out using screws, which we'll remove later. But it's not good, because the hull gets all marked up. It ends up with a bunch of scars inside, with little screw holes. I need to tell you guys that I love epoxy, but it takes a while to cure. Epoxy, for it to get hard, and since it takes over 24 hours, you can't apply it and immediately sand or rely on the glued area. That's a problem for us, because everything must be carefully planned. To Tomorrow, I need to sand it, then glue another piece on top. Wait another 24 hours to sand it again, then apply the fiber, put epoxy on top, and wait another 24 hours. And that's when we're talking about a really tight schedule, with just these few days left for us to get the boat ready to sail in the wind. It's pretty complicated. So what did we do? While the epoxy was curing, we took the opportunity to work on these smaller parts, like the centerboard, the rudder, and the benches, which can be worked on in parallel. But then, once again, we have to join the two parts with epoxy. And some of these pieces, we also need to apply a layer of fiberglass on top, then finish it with aerosol. It takes days for a piece like this to be ready. We decided to make the boat seats and the mast bench out of solid wood because they need to be very strong, and it also looks nice in the final finish. Another part that's quite delicate on the boat is aligning the mast. At the top, it's attached here to what we call the mast bench, but at the bottom on the hull, it has a fitting, and these two parts, the bench and the fitting, have to be aligned. The mast must be perfectly vertical, and the piece below needs to be glued correctly. We're going to use a mast that's not exactly very straight, and I'll talk more about it later. But we set up a laser level there and started fitting the mast support underneath. Well, I've talked too much sitting here already. I need to help the guys finish this boat because we're going to need to do a rowing test before it sails. Let's get our hands dirty a little more. What we're doing now is pretty much the final stage of the hull before the varnish, applying a layer of that epoxy with the ultra-fine sand powder with aerosol, and then a layer of liquid epoxy on top. The idea is to create a kind of glass here, like the lid of a piano. We're not going to get that far. But if you look against the light, it almost looks like water. We're going to varnish the inside of the boat now, and this has two purposes. The most important thing is that epoxy resin can't withstand the sun's ultraviolet rays, so the epoxy starts to degrade in the sun, and the varnish protects it. This one is a varnish with triple protection, and all that. But there's a second function that, for me, is even more important. I want to keep the wood color on the inside, but there are these stripes here, and they're just too ugly. The idea is to darken this wood, which is too light, so the contrast is less noticeable. 3 things are missing under the boat before pool testing. First is a skeg. It's a kind of protection for the rudder if the boat hits something. For example, it will hit this piece of wood before it hits the rudder. The keel, a thin strip of wood running the boat's length, not only serves its usual function, but also reinforces the structure in our boat. The bottom becomes sturdier. And finally, 2 R-locks are still added, which is this hardware that we ordered from Gustavo, from Madeira Mar, which is used to secure the oars when moving the boat. Today is a good day to put the boat in the pool because there's a real risk. If we flip the boat and fall in, we'll die from contamination. This pool has never been so green. That's a lie. I think there have been much worse days. Now, for real, huh? Is it official? 1, 2, 3, and... Rowing positions 4. When I return, I can't lower it much because the oar hits my leg.